As enterprises evolve their compute in the cloud era, they are connecting to multiple cloud providers based on their unique requirements. The data processing, training, and inference for machine learning are proliferating across multiple clouds. This solution showcases the training in Google Cloud Vertex AI platform, with data extracted from an enterprise database, running Google Cloud VMware Engine to cloud storage. GCVE allows you to lift and shift your VMware-based applications to Google Cloud without changes to your apps, tools, or processes. The service provides all the hardware and VMware licenses you need to run in a dedicated VMware SDDC in Google Cloud. Google Cloud Vertex AI is a unified MLOps platform to help data scientists or ML engineers increase experimentation, deploy faster, and manage models with confidence. It also helps to build advanced ML models with custom tooling. 2 AI-based applications for the finance and healthcare verticals are showcased in the solution. Finance application uses the data stored in a Microsoft SQL Server-based enterprise data repository running in GCVE. Nightly incremental data is extracted to Google Cloud Storage and used in model training. Healthcare AI app with CT scan-based COVID-19 image detection. Image data is transferred from GCVE to Google Cloud Storage for Vertex-based training. Let us understand the solution flow. On-premises data is transferred to GCVE. Data is then moved to Google Cloud-based storage. Data is extracted and used for training in Google Cloud Vertex AI for the 2 AI applications. The trained model is deployed to endpoints in the hybrid cloud using Vertex ML Edge Manager. The stock market data from an on-premises SQL database is replicated to a GCVE-based Microsoft SQL Server instance, the details of which are shown. The data is extracted in CSV format and copied to Google Cloud Storage. For the finance industry use case, Google Cloud Vertex AI is used to train the stock market prediction model as shown, using AI or ML-accelerated Google Cloud instances with GPUs. First, we check that the data has no null values. We can confirm the same in the first few rows here. The data plotted across several years is shown here. We split the data into training and testing. Here we can see the LSTM model. We then save the model file on Google Datastore. Now we are training the model using stock data. Here we can see that the GPU is fully utilized during training. The training is now complete. And this is the saved model file. The testing of the model is now being showcased. We see the actual values plotted along with the predicted value. For the healthcare use case, GCP Vertex AI is used to train COVID-19 detection AI application with existing labeled COVID-19 CT scans, as shown. The CT scan image data is uploaded from GCVE to Google Cloud Storage, which is then accessed from Google Cloud Vertex for training with specialized GPU instances. We further fine-tune the model and save the model file. The distribution of COVID-affected and non-COVID cases identified through CT scan is shown here. The data is split for training, validation, and testing. Here are some sample CT scan images from our dataset. This is the model we use to train our dataset. The training is run as shown. The training is now complete. We further fine-tune the model and save the model file. The model file is saved, as shown here. The prediction, based on the model, is shown here. Here you can see that the prediction and actuals match. In summary, Google Cloud ML or AI apps can be effectively combined for end-to-end multi-cloud AI or ML. Enterprises can leverage GCVE to extend their data and processing to the cloud. Many of the best-of-breed capabilities of Google Cloud Vertex AI can be accessed and leveraged effectively by data scientists and ML engineers. VMware-based multi-cloud provides for efficient distribution of AI or ML models developed in Google Cloud across disparate edges and endpoints.